So we want to continue graphing rational functions. So we're going to start our analysis with this function, where we find the vertical asymptotes first. So how do you find vertical asymptotes? You'll focus on the bottom factors. Right, you set those equal to 0, so I'm going to take x minus 4, set it equal to 0. I'll get x equals 4 when I have 4 to both sides, and that has multiplicity 2, which is even multiplicity 2. Why even multiplicity 2? Well, you have a power of 2 right there. Okay, and I'm going to look at my second factor, x plus 4. Set that equal to 0. When I subtract 4 from both sides, I get negative 4 as my vertical asymptote. X equals negative 4. That has an odd multiplicity 1. Imagine a power of 1 up there. Okay, so next we're going to find our horizontal asymptote. So first we're going to look at the degree of the top. The degree of the top, I'm going to call the top f of x, is 1, right? 1 up there. And I'm going to look at the degree of the bottom. It has a power of 2 and a power of 1. We'll add those multiplicities and get total degree of 3, so the top definitely has a smaller degree than the bottom. Since it has a smaller degree than the bottom, then you're going to have a horizontal asymptote at y equals 0. Horizontal asymptote at y equals 0. Okay, so y equals 0 is just the x-axis if you graph that horizontal line. All right, so also we want to find any x-intercepts, also called zeros or roots. To do that, you take your numerators, your numerator factors, and set them equal to 0. So we just have x equals 0. Hey, that really doesn't require solving. That has multiplicity 1. Has odd multiplicity. Why does x equals 0 have multiplicity 1? Well, if you look at the factor here, x, it just has a power of 1. You don't see the power of 1, but imagine a power of 1 up there. Yeah. Okay. And the last thing, the last really big thing we want to do here is, oh yeah, y-intercept. Y-intercept. To find a y-intercept, you just plug in 0 for all the x values. So I'm going to have blank minus 4 squared over blank plus 4. I'm going to plug zeros for my x's. So I'm going to have a 0 up top. I'm going to have 0 minus 4 squared. I'm going to have a 0 plus 4. And let's see, on top I have 0. On bottom I have negative 4 squared times 4. It's going to be 0 over 64. Well, 0 divided by anything else is 0. So y equals 0 is the y-intercept. Okay, let's plot these things out here. Let's get a graph going. So our vertical asymptotes are negative 4 and positive 4, or 4 and negative 4. 1, 2, 3, 4. 1, 2, 3, 4, negative. Those are our vertical asymptotes. Horizontal asymptote is y equals 0. Y equals 0 is just the x-axis. We have an x-intercept at 0. It's right here. So we're hitting right here at x equals 0. So I'm going to put a red point. My graph is going to be in red. I'm going to have a y-intercept at 0 as well. So I have a y value. I'm hitting the y-axis there at y equals 0. Okay, so x equals 0, y equals 0, the same thing. Okay, so that's all we know so far. So what we have to do, we have to look on our different x values that are important. So we know -4 is an important x value, even though it's not part of the graph, it's a vertical asymptote. We know 0 is an important x value. It's actually an x-intercept and a y-intercept. And +4 is an important x value, even though it's not part of the graph, it's a vertical asymptote. So I'm going to take the rightmost one of those. What's the rightmost one of those important x values? 4, right? X equals 4. And we're going to pick a point to the right of that, which is going to be 5. So I'm going to pick 5. I'm going to set up a test point with 5. So let's take 5 and set up a test point. So what happens at x equals 5? I'm going to plug in 5 into my function. What's the y value going to be? Y equals blank over blank minus 4 squared plus blank plus 4. So here it goes. I'm plugging in a 5 for my x's. 5, 5, 5. So I'm going to get my y value is 5 over 5 minus 4 squared is 1 squared. 5 plus 4 is 9. So I'm going to get 5 9ths. So when my x value is 4, my y value is 5 9ths. So where's 5 comma 5 9ths? 5 comma 5 9ths. Well, if we imagine this is positive 1 right here on the y-axis, 5 9ths would be almost halfway between 0 and 1. So 5 comma 5 9ths would be right here. That little purple point that I made there on the right side. Now, why did I create this point on the right side? I want to know where my graph is going. Is the graph up here in this upper right corner, or is the graph down here in this bottom left corner? Well, according to our point, we know the graph is in the upper right corner. So the graph, I'm going to make this a red dot now, is going to be up here. So our graph has to follow the vertical asymptote and it has to follow the horizontal asymptote. So it's in that upper right corner there on the far right. Okay, so we have the upper right side done to the right of the vertical asymptote 4. What about on the left side of the vertical asymptote 4? Well, let's focus on our vertical asymptote 4 here. Had even multiplicity, right? Even multiplicity. So that means on the other side of our vertical asymptote, the graph's going to be going in the same direction, right? Even multiplicity means same direction. So when we go to the left side of the vertical asymptote 4, our graph is also going up, same. So our graph goes up, and then it has to, as it goes left, it has to connect to this x-intercept. We have to connect to it, we're required to. Now, what does it do at the x-intercept? Now, this x-intercept here is 0. So this had, if you look here, x equals 0, our x-intercept had odd multiplicity. So do we kiss at 0 like that? Do we come back up? Or do we cross at 0? Do we go down? We have to kiss, right? Odd multiplicity says kissing. Crossing. Odd multiplicity says crossing. So we're going to cross. Say it correctly, cross. Now, here's a question. Is our graph, which is now below the x-axis, is it allowed to come back up above the x-axis and go up towards this new vertical asymptote? No. If we had to come back across the x-axis and go up towards the vertical asymptote at -4, we'd have an x-intercept somewhere, right? We'd be crossing the x-axis. So we're not allowed to do that. So that means we're only forced to go in one direction. We are forced to go down. Forced to go down. So I don't like that very much. Let me do it like this. How about that? That's better. Okay, so we're going to have to go down towards the vertical asymptote, because going up would require crossing the x-axis, which we don't have any places to cross the x-axis anymore, right? We don't have any more x-intercepts. Okay, so we're going down towards the vertical asymptote of -4. So what are we doing on the left side of the vertical asymptote at -4? What's going on the left side? Well, let's focus on the vertical asymptote at -4 here. So at -4, you have an odd multiplicity. So that means on the other side, you're going to be doing the opposite direction. So we're not going down that way. We have to be going up this way, because that was opposite. The opposite of going down is going up. So we're going to be going up here, and then we're going to have to, well, as we go to the left, we have to approach the horizontal asymptote. So there's a good graph there. Pretty good graph. I mean, it's not super accurate, but it gives you the general picture. It gives you the general shape of things. And that's our goal, to get the general shape of things. Okay, I'm going to do another example. So that one we had to actually factor, right? We had to... No, that one was factored for us. That's nice. It's nice when they factor them for you. Okay, here's a number 3. This is a number 3. I'm going to call r of x equals x minus 2 on top, and on bottom x plus 1 squared. So this one's already factored as well. That's nice. So let's first find the vertical asymptotes. So to find vertical asymptotes, I'm going to take my bottom factors and set them equal to 0. I only have one factor in bottom right. I have x plus 1. Set that equal to 0, and I get a vertical asymptote at -1. Has even multiplicity. The multiplicity is 2 here, right? That's that power in the bottom. The power of x plus 1 is 2. Okay, so we have one vertical asymptote. That's it. Let's find the horizontal asymptote if we can. So we're going to focus on the degree of the top and the degree of the bottom. The degree of the top, I'm going to call the top f of x, has degree 1, right? The power is 1 up there. And the degree of the bottom, called the bottom g of x, that has degree 2 right there. So the top has a smaller degree than the bottom. Then there's a horizontal asymptote at y equals 0. Okay. What else do we want to do here? We also want to do X-intercepts. How do we find X-intercepts? We take the top factor, set them equal to 0. We just have one top factor of x minus 2. Set that equal to 0. We get x equals 2 has odd multiplicity 1. Why odd multiplicity 1? Well, if you look at x plus 2, imagine parentheses here, there's a power of 1 out there that you don't see. So that's an odd multiplicity. And finally, we want our y-intercept. So we're going to take our function and plug in 0 everywhere for x. I'm going to plug in 0 for x, and on top I'm going to have 0 minus 2 is minus 2, and on the bottom I'm going to have 1 squared, so that's going to give me y equals -2 over 1, which is -2. Okay, let me see. Okay, that works. So I want to get to graphing this. So we're going to put down our vertical asymptote at -1 here. We're going to put down our x-intercept. Horizontal asymptote here at y equals 0. It's the same as the x-axis. We're going to put down an x-intercept at +2, 1, 2. So I'm actually going to put a dot there, a red dot for our graph, and we have a y-intercept at -2. So I'll put a red dot there. So, what's going on here? What's going on exactly? So we need to get a test point. To figure out what's going on the right. So you always want to start from the right. A test point. And when I pick my test point, I always take it to the right of the rightmost x value that's important. So we have x values that are important are -1. -1 is an important x value. It's our vertical asymptote. Then we have 0. An x value of 0 gave us our y-intercept. Then we have an x value of 2, which gave us an x-intercept. So I'm going to take an x value just to the right here of 3. I'm going to plug that in to find out what's going on here on the right. So at x equals 3, what's y doing? So I'm going to plug into my function 3. I'm going to have a blank -2 over blank plus 1 squared. We're plugging in 3 for x. So for y, we're going to get 3 minus 1 is 1 over 3 plus 1 is 4 squared. It's going to be 1 over 16. So at x equals 3, y equals 1 over 16. So let's plot that. This would be 1 here. I don't like my horizontal. Let me try to redraw my horizontal asymptote. It looks like it doesn't look too good, my horizontal asymptote. My horizontal asymptote is supposed to be the x-axis. Right? Y equals 0 is the same thing as the x-axis. Okay, where is 3 comma 1/16? 3 comma 1/16 is somewhere like right here, right? It's just above the x-axis. Just above the x-axis. So that means, so focus on your x-intercept in that red point I'm going to be making. Okay, so it's turning red. It went from purple to red. So these have to connect, okay? Between 2 and 3, those have to connect. But remember that as you go to the right, as you move to the right further and further, you have to get closer and closer to the x-axis because the x-axis, y equals 0, is a horizontal asymptote. So on the right side, you have to come back down and approach the x-axis. Now what happens at x equals 2? What happens at x equals 2? Do you cross or do you kiss at x equals 2? Let's see, we have an x-intercept here at 2 that had odd multiplicity. So since it had odd multiplicity at x equals 2, you're going to cross here. You're going to come across and you're going to have to connect to the y-intercept, which is at y equals -2. Now here's the question. Is it possible to go from that y-intercept at -2 and come back up towards the vertical asymptote? Is it possible to do that? No. Why is it not possible, you're maybe asking? Because there is no x-intercept between 0 and -1, right? So there have to be an x-intercept right there, and we know there is no x-intercept. There are no more x-intercepts, so you can't do that. That leaves just one option. You have to follow your vertical asymptote downwards. So your vertical asymptote is going to go down like that. Okay? Now this is what's going on to the right side of the vertical asymptote at -1. Now we have to figure out what's going on the left side of the vertical asymptote at -1. So look at your vertical asymptote here. -1 had an even multiplicity of 2. So it has an even multiplicity. That means on the other side, that would be the left side of the vertical asymptote, your graph is doing the same thing, has the same orientation. So since it was going down as you come from the right, it has to be going down as you come from the left as well. And then the graph has to come up, and it has to approach the horizontal asymptote here on the left. Oh, there it is. There is a generic graph of your function. I don't like how this is. Let's make this a little cleaner. I want to make this just a little bit cleaner here in red. Okay, that looks better, I think. All right, so this is the function R. Interesting. Oh yeah, you get weird stuff sometimes. So remember, it's okay to hit or even cross the x-axis like we did here at 2. It's just on the tail ends as you go to the right, you have to get closer and closer to the horizontal asymptote, and on the left, you have to get on the tail end of the left, have to get closer and closer